Hello, and thank you for participating in this series of presentations. I am Dale Beach in the Department of Biological and Environmental Sciences at Longwood University. I will be talking today about our continuing work to refine and implement the General Education Goal 6 courses through better course planning and increased compliance and assessment. In addition to being a 2013 Longwood Assessment Mini-Grant Program awardee, I am currently the chairperson of the Goal 6 Assessment Committee. The General Education program at Longwood is divided into a series of specific goals. Each General Education goal is supported by one or more courses offered by various departments and academic disciplines. Each General Education goal program is assessed according to specific and measurable objectives that determine the role and impact of goal courses on student learning and achievement of overall General Education objectives. In this presentation, I will be focused primarily on courses and instructors participating in the Goal 6 General Education courses. Goal 6 objectives seek to develop a better appreciation for the methods and contribution of science to society and the cultural application of scientific discoveries. Some topics include Alexander Fleming's discovery of antibiotics and the resulting contribution to medicine, or perhaps the continuing development of nuclear capabilities for both peaceful or violent action. As with other general education goals, there is no single best course that satisfies the general education requirement. Instead, several courses are available to address student interests and skill development. Goal 6 courses are currently offered through the departments of chemistry and physics and biological and environmental sciences. Students can select from topics such as chemistry, physics, astronomy, biology, and environmental science. Our department also offers a variable topics course called Exploring Science in Our World. Recent offerings of this course include Biology of Water, the Biology of Stress, and my own online course, the Biology of Food. All of these courses are assessed against the same set of student learning objectives. One of our primary challenges has been to implement assessment tools that can be readily applied to all of these diverse topics. The Goal 6 requirement includes 3 student learning objectives. The first objective asks students to learn and understand the major methodologies used in scientific inquiry. Generally, the scientific method of asking questions, hypothesis formation, and experimentation to determine the best solution is developed as part of this objective. In most courses, this objective is addressed in required laboratory sessions through experimentation, analysis of novel data sets, and the communication of their own experimental outcomes by students. The second objective asks students to recognize and explain how major scientific discoveries contribute to our cultural heritage. Courses typically use in-class discussion or short research projects to promote student-centered exploration of a targeted scientific discovery or technology and the effects on our own culture. And the third learning outcome seeks to bring the students' focus to contemporary issues affecting our society and how science is being used to seek answers. Examples here can be taken from any noteworthy news source, and often courses utilize recent news stories in the lay press for student review and discussion. Topics may include anything from the application of the human genome sequence information in medicine to the development of, say, new batteries for cell phone or electric car industries. Past rounds of assessment review have demonstrated some consistent issues with our program. First, the Goal 6 courses are often taught by adjunct, visiting, or newly hired faculty. These folks are just getting their feet wet in the Longwood community, may have little experience teaching, and often have additional course responsibilities. Learning the assessment regime and designing the required assignments may take a back seat to simply getting the course underway. Further, as entering faculty, they are certainly unfamiliar with Longwood's general education program, the goal program, and the combination of learning outcomes and assessments required in these courses. Second, students taking the courses are not necessarily majors and are essentially out of their comfort zone. For most of these students, course topics are conceptually challenging. Further, many may not be familiar with some of the basic methodologies and expectations typical of a science course. One example that I will discuss further is the restrictive format common to scientific communication, and specifically graphing data generated in laboratory experiments. And third, given the diversity of courses representing the fields of biology, chemistry, and physics, we have been working to develop a single set of assessment tools for each learning objective for equivalent evaluation of all of our courses. Previous work by the Goal 6 Assessment Committee have produced a set of parallel assignments in all of our Goal 6 courses that facilitate assessment of each objective using a single set of directed essay questions. The work presented today reflects a continuing effort towards a unified complement of coursework and associated assessment instruments for the entire complement of Goal 6 courses. Given the breadth of the courses satisfying the Goal 6 requirement, we have instituted a very prescribed assessment program to provide consistent assessment across different disciplines. It is essential for compliance with this program that faculty are provided the correct materials and be instructed in their use. To ensure that faculty teaching in the Goal 6 program as new faculty or as a new teaching assignment, this program aims to provide the necessary information and background to inform faculty of the assessment program, assist in course development, and provide assessment materials that fit our evaluation criteria. And an important part of the program is simply to introduce faculty to the expectations and requirements that are associated with teaching a general education course. Our primary goal is to provide a suitable framework to quickly educate the teacher and facilitate better communications of the Goal 6 requirements. Second, we wanted to ensure that all instructors had a complement of updated materials for assessment. By distributing a common source of templates, all of our instructors will be using a consistent set of instruments for their assessment and improve compliance with our overall assessment program. Finally, we wanted to assist in the course design by informing our faculty about available, prepared assignments that can facilitate the assessment materials and provide examples of student outcomes. While we support the academic freedom of faculty to design and implement their own courses, we feel that by providing these materials, new faculty have the necessary information to accurately prepare courses that are compliant with the general education expectations and address specifically the Goal 6 learning outcomes. So why is this program essential for our assessment? Well, because nobody wants to see a teacher as confused as this poor fellow, and certainly no faculty, chair, or dean wants to see this student coming towards their office door. So if we want to promote student excellence in general education, we need to ensure that we have well-supported and informed faculty. So to address our need to better communicate the expectations and requirements of the Goal 6 general education program, we have assembled a comprehensive set of documents to inform and support instructors teaching their representative courses. The package includes an orientation document entitled A Crash Course in Surviving the Goal 6 Teaching Experience, which I will describe in more detail in a moment. It includes a more detailed information describing the assessment program in a document entitled A Unified Goal 6 Assessment Strategy, a set of templates of the survey instruments used in the assessment program, and finally, some examples of course assignments and course work. In the orientation package, we ask faculty to first review the document, A Crash Course in Surviving the Goal 6 Teaching Experience. In this initial short document, we provide an informative summary of the assessment program and Goal 6 requirements for our new faculty. Highlights of the document include the background of the Longwood General Education Program, a description of the Goal 6 student learning objectives, examples of typical assignments used to address the learning outcomes, and information to help faculty complete the assessment requirements. This excerpt from the crash course document, The Lowdown on Goal 6, demonstrates a concise paragraph including information about the learning objectives prescribed in the Goal 6 requirement, highlighted here at the top, the requirement for assessment of student success here in the middle of the document, and the use of cross-discipline surveys to collect supporting evidence of student success down here at the end. While this paragraph is limited in detail, the goal of this document is to orient the instructor. Again, additional details are provided in other documents so that the crash course can promote a conversational overview of the program before submersing faculty in all of the details. The conversational aspect of the material continues with a very simple question. How might I address the 3 outcomes in my course? The crux of the matter for any instructor is integrating these expectations into their developing course. This section is abbreviated here to demonstrate very simply the examples offered to faculty to address each of the individual outcomes. As shown, 3 outcomes can be addressed through typical assignments, including laboratory experiments. These are included in all of our Goal 6 courses. A short scholarly review paper to develop broader topics, and finally by reviewing current news articles from popular press. Again, details are left out to keep the document brief and allow individual faculty the academic freedom to develop each assignment according to their vision of each course. Once faculty have reviewed the crash course, we hope that they have enough information to more responsibly address the Goal 6 program requirements. Next, they are directed to explore the rest of the information on the CD-ROM, including the more detailed descriptions of the program and additional example material. As the second objective of our program, we wanted to increase compliance of faculty with the assessment program. Some of the common issues occurring in past reviews are simply that faculty did not know that assessment materials were required for the Goal 6 courses, or materials submitted were unusable because they did not meet the requirements of the assessment program. Again, we expect that improved compliance will result from better communication of program needs. These expectations are first addressed in the crash course document and then more clearly developed in the included document, a unified Goal 6 assessment strategy. In addition, we provide a set of survey templates for each of the 3 objectives to ensure that faculty have models to use in building their own materials. Customizable survey templates, of course, the templates simply demonstrate the general format and critical information required for the assessment program. Faculty must edit them to fit their course. This template shows the style of questions expected for student learning outcome number 2, where students will recognize and explain major contributions of science to our cultural heritage. Students were asked to complete this survey after completing a report on the discovery of DNA structure by Watson and Crick. As outlined in the assessment program, students are expected to, first off, emphasize and discuss the significance of the scientific contribution. Second, they're asked to discuss how the contribution affects culture, then discuss how the contribution affects them personally, and finally, the students are asked to simply include a set of scholarly references that they had used in their prepared document. Not only do these templates provide the instructors with the appropriate tools to complete their assessment, but the consistent formulation of the templates ensures a more cohesive and unified review by the assessment committee, especially considering the breadth of courses to be reviewed in the Goal 6 program. The third and final objective of this project was to assist the course design and content by providing examples of previous assignments, as well as representative examples of student work. We have already talked quite a bit about example assignments, including laboratory exercises, current events, and research papers. Here, I want to focus on the examples of student work. Ideally, we can provide instructors examples to help them identify student preconceptions and misunderstandings so that they can integrate appropriate course material to address student needs. In the following examples, we will use the topic of scientific communication of data as an example of a topic often difficult for many students to grasp. This topic is part of the assessment for the student learning outcomes number 1 regarding the methods of scientific inquiry. In this example, students were asked to graph a set of data similar to that generated during one of their laboratory experiments. In this case, the students had already completed the experiments and received feedback on the graphs that they presented. For the consistency of the student evaluations, all of the students were asked to graph the same data set in this case. I've used Excel to prepare the expected graph here, showing the data in the table to the left and expected graph on the right. In this case, the vertical and horizontal axes are labeled, the graph has a title, and the data points are plotted here as blue diamonds. As demonstrated From this graph, we can explore the relationship between the melting temperature on the y-axis of each type of cooking fat and the relative proportion of saturated fat in the oil. The resulting scatter of points can then be interpreted by the student to provide evidence for a final conclusion. Either there is a relationship and we can predict melting temperature from the amount of saturated fat in the oil, or there simply is no relationship, and these two properties of cooking oils are not related. The black line and the algebraic expression are my additions and wouldn't be expected of a student except maybe more advanced students. Or perhaps this may be requested by an instructor as an example of statistical analysis of the data. In this first example, the student has correctly graphed the data, including titles for the graph and both axes, and correctly displayed the data. This example would be scored as successfully meeting the criteria depending on the student's supporting description of their conclusions. In a second example, the student has submitted a graph that is technically incorrect. The blue line connecting the data points should not be shown. In this case, the line simply links successive data points in the order that they were listed in the table. If the table were reordered, then the graph would change even though the data would not. In this case, we cannot be certain if the student understands the concept of mapping or if they are simply having trouble using Excel to prepare the graph. Given this example, an instructor may decide to include a demonstration or additional materials for the use of Excel, or just avoid using computer-based graphing systems. Finally, in this example, the student does not appear to understand the role of using a graph to display the relationship of the data. Instead, this graph makes two critical errors. First, the two columns of data are plotted as independent information, where we are asking whether the two pieces of information are linked as a physical property of these oils. When separated, no conclusions can be drawn. Second, the type of oil is a discrete piece of information. Each oil is different and separated from the other oils. In comparison, variables like temperature are continuous in that there is a continuity of values between a temperature of, say, 20 degrees and one of 25 degrees. The line graph shown should only be used for continuous traits of data, such as temperature or the percent saturated fat. In this case, a bar graph would be more appropriate for what the student is trying to prepare. Again, in planning out their courses, an instructor may decide to include more time discussing how to accurately display different types of data after reviewing these examples. So our goal in including this material is to provide additional support to instructors to adapt their course and address the needs of the student. Although we focus on one example here by providing this additional information to instructors, we hope that they can more completely address the student learning objectives associated with the Goal 6 requirement and improve student success in these courses. In conclusion, our general goal for this project is to increase the level of clarity of our communication with new and existing faculty teaching in the Goal 6 courses, to increase participation and compliance in the Goal 6 assessment program among all of our instructors. We have assembled a comprehensive collection of material to guide them through the design and implementation of their courses, as well as complete the assessment requirements. The work presented here is a culmination of work by the Goal 6 Assessment Committee in developing materials that support our program. This is the first inclusion of the crash course in surviving the Goal 6 teaching experience and the first assembly of this information packet for new faculty to disseminate as a CD-ROM-based package. In the end, we hope that we are able to effectively communicate our expectations for the assessment program. These materials were first distributed in the fall of 2013. We have not yet reviewed the assessment material produced in the fall semester, and we are now preparing for the spring semester with a few tweaks to the packet. However, anecdotal comments from professors indicate that the materials have in fact been helpful in their understanding of the Goal 6 assessment program. To continue to support student and faculty success in the Goal 6 courses, we plan to expand the material included on the CD-ROM to bring in more examples from chemistry and physics courses and provide additional examples of course assignments from different courses as well as student work. As part of this online presentation, we will be providing a copy of the crash course in surviving the Goal 6 teaching experience and a unified Goal 6 assessment strategy for your review. I would like to thank the Longwood Assessment Mini Grant Program for their support in creating this material, and thank you for your time and attention.